Welcome. This is the 8th study session of MTH 102 General Mathematics 2. This particular study session is divided into two parts. This is the first part, and we are going to be discussing about application of differentiation. Introduction. Differentiation is very helpful in solving many types of real-world problems. The knowledge of differentiation is needed in science, economics, engineering, and some other courses. You will meet advanced form of differentiation as you advance with your studies. You must understand the derivatives very well because it is the bedrock of everything in differentiation. You can use the knowledge of derivative to determine maximum and minimum value of a particular function, e.g. cost, strength, amount of material, profit, etc. Also, derivatives are met in many engineering and science problems, especially when modeling the behavior of moving objects. In this study session, you will learn about the application of differentiation in rectilinear motion, target and normal motion problem, a maximum and minimum value problem. Learning outcome. On completion of this study, you are expected to be able to use knowledge of differentiation to solve rectilinear problem, also to solve target and normal related problem, and maximum and minimum value problem. Application of derivatives in rectilinear motion. Derivatives can be used to calculate instantaneous rate of change, that is, the rate of change of position with respect to time, which is known as velocity, and the rate of change of velocity with respect to time, which is known as acceleration. You know, like the statements mentioned earlier, velocity is the first derivative of displacement, while acceleration is the second derivative of displacement, or the first derivative of velocity. Using this idea, we'll be able to analyze one-dimensional particle movement problem, given position as a function of time. Let's solve an example so that you can understand what I just explained to you better. Example 1. A ball thrown straight up has a height expressed with the function shown on your screen. That is, f of t equals minus 16t squared plus 160t. After t seconds, find maximum height and the velocity when it hits the ground. In order for you to solve this kind of problem, the first question says find the maximum height. Recall that we said velocity is the first derivative of displacement, and displacement is expressed as shown on your screen. That is, f of t equals minus 16t squared plus 160t. So in order to find a solution to the maximum height, we are going to first picture this in a practical form. You know, when you throw something up, the maximum height here is when the velocity at which the ball is thrown equals 0. So at this point, the ball begins to come down again. So in order to find our maximum height is going to be when v equals 0. And before we can find v, we are going to differentiate this expression of displacement shown on your screen. So let's solve this so that you can get it better. Now, the expression says f of t equals minus 16t squared plus 160t. That is the expression. Now our velocity is going to be differential of displacement, which is going to be minus 32t plus 160. Now recall, we said the maximum height is when velocity equals 0. So 0 equals minus 32t plus 160. Making t the subject of the formula, we are going to have t equals 160 over 32, which is going to give us 5 seconds. So when we know the time it took to get to maximum height, then we substitute the value of t into the expression of the displacement. That is, our f of t is now going to be minus 16 5 squared plus 165, which is going to give us our maximum height, which is 400 units. This is our maximum height. I hope you get the problem I just solved to you now, because just practicalize it. You throw something up at this point, your velocity will be 0, and that is your maximum height. That is, h will be maximum. Then the ball begins to drop down again. Now let's proceed. Now the next question said we should find the velocity when the ball hits the ground. That is, when the object is thrown up. So what is the velocity at this point? You know, we know that velocity at this point is 0 here. So we should find the velocity when the ball hits the ground. In order to find the velocity when the ball hits the ground, one thing is certain: when the ball hits the ground here, our f of t is going to be 0. That is, the height of the object, you know, is going to be 0. So when the height is 0, and we know we've calculated that t, time taken to reach maximum height here, is 5 seconds. So time taken to reach the ground here also will be 5 seconds. The t to reach. So the total time the ball took to travel is going to be 2 times 5, which is going to be 10 seconds. So we just substitute the value of t here into the expression of velocity we derived the other time, which gave us this expression, minus 32t plus 160. So when we substitute it into this place, we are going to get 32 multiplied by 10 plus 160, and we are going to get our answer to be minus 160 units per second, which is the unit of velocity. The reason why it has a negative sign is because the ball is decelerating. Okay, let's proceed. Now this is another example, example 2. The distance covered by a moving body after t seconds is given as the expression shown on your screen, as f of t equals t raised to power 3 minus 3t squared plus 2. Find acceleration of the body when t equals 2. Then at what time will the acceleration equal to 0? Now let's solve this example also, so that you can have a broad idea of what we are discussing. You know, the expression given for displacement is t raised to power 3 minus 3t squared plus 2. Now, in order to get our acceleration, you know, when we started this topic, we said acceleration is the second derivative of the displacement. That is, the first derivative of this displacement is going to be 3t squared minus 6t. So the second derivative is going to be (60) minus 6. So since we've gotten this value, so we should find the acceleration That is the second derivative when t equals 2. So what we just do is to substitute the value of 2 into t. So we have 6 multiplied by 2 minus 6. So we are going to have 6 meter per second square, or rather, depending on unit that is being used, we say unit per second square. Now, the second question is that at what time will the acceleration equal to 0? Now, in order to find that question, say what time will the acceleration, that is the second derivative of the displacement, be equal to 0? And recall that we said the second derivative is expressed as 6t minus 6. So we just equate it. When this is 0, we are going to have 6t minus 6. We make t the subject of the formula, and we are going to have 6t equals 6. And t the subject of the formula, we have 1 second. As simple as ABC. Now, the next one we are going to be discussing is how to apply differentiation to tangent and normal problem. So this example talks about gradients of tangent and normal. Then find the gradient of the tangent, then the normal to the curve, expressed as y equals x raised to power 3 minus 2x squared plus 5 at point 2, 5. So the solution is as shown on your screen. The solution is as shown on your screen. Now, you know we have the expression y equals x raised to power 3 minus 2x raised to power 2 plus 5. In order to find the gradient of this expression, we are going to differentiate the particular expression. So when we differentiate it, we are going to have 3x squared plus 4x. This is our differential value, and from there we are going to calculate the slope of the tangent. So in order to calculate the slope of the tangent, we substitute the value of x into the derivative that we just calculated. So we are going to have 3 into 2 raised to power 2 plus 4 into 2. Then we have our answer to be 4. Now, in order to find the slope of normal, the formula to find that is m1 multiplied by m2 equals minus 1, where m1 is the slope for the tangent and m2 is the slope for the normal. So we make m2, which is what we are looking for now, the subject of the formula. So when we make m2 the subject of the formula, we are going to get our gradient for the normal to be minus 1 over 4. Now, example 4 said find the equation of the normal in example 3. You know, the solution is as shown on your screen. What the solution is trying to do is that when this particular expression can be gotten from our change in y, that is y minus y1 over change in x, x minus x1, is going to be our gradient. From here, you make from this particular expression, you are going to get this. And recall that from the question, we have our x to be 2 and our y to be 5. And we have calculated our gradient to be normal, that is m2, to be minus 1 over 4. So if you substitute all these values into the expression shown on your screen, into this expression, we are going to have our final answer, which is x plus 4y minus 22 equals 0. Now the next one is how to apply differentiation to maximum and minimum value problem. Now the process of finding maximum or minimum value is called optimization. We can try to do things like maximize the profit of the company, minimize the cost, or find the least amount of material to make a particular object. These are very important in the industry. Now let's solve this example so that you can understand this better. Example, this is going to be the fifth example. Now, it said the daily profit of an oil refinery is given by the expression P equals 8x minus 0.02x squared, where x is the number of barrels of oil refined. How many barrels will give maximum profit, and what is the maximum profit? Now let's solve this particular question so that you can understand it better. The question said P is 8x minus 0.02x squared. That is the expression. Now the profit is going to be maximum when our dP dx, that is change in price with barrel, equals 0. Our price is going to be maximum, that is P will be maximum. So from here, our dP dx is going to be 8 minus 0.04x. So when this equals 0, we make x the subject of the formula. So we have our x equals 8 over 0.04, which is going to give us 200. Now the question is, how sure am I that this is a maximum value that I'm looking for? In order to get that, he said is the square P dx squared. What will be the value? Is going to be 0 minus 0.04. Now, is this greater than 0? No. So since this is not greater than 0, then we say our answer is maximum. So we are going to have our maximum price to be $800 and our maximum barrel to be 200 barrels. You know how we got the 800? We just substitute the value of x, this x, into this, then we get our answers. Let's move on. Now, this is another question concerning the maximum and minimum. So a rectangular store area is to be constructed along with the side of a tall building. A security fence is required along the remaining 3 sides of the area. What is the maximum area that can be enclosed with 800 meters of fence? Now, in order to solve this particular problem, it's very important that you be able to picture the problem. Now, this is the fence, and this is the wire area. Now, in order to get this, the area is expressed as length times breadth. That is why we have x multiplied by y. Now, the maximum area that can be enclosed by 800 meter fence, which is this area, is now going to be x plus x plus y. That is why we have 2x plus y equals 800 as shown here. So from this, we are going to express y in terms of x, which gave us this. So we are now going to substitute this into the value of the area here. That is why we have this particular expression, that is 800x minus 2x squared. Now, in order to maximize the area, we said our change in area with respect to x will be equal to 0. So from here, we were able to get our value of x to be 200. Now the question again is, how sure am I that this particular 200 is the maximum? Now, in order to answer that question, we are going to find the second derivative of the expression, that is 800x minus 2 of this expression, 800 minus 4x. So the second derivative of this expression is going to give us -4. Now, and like in the first example, the previous example that we did, that we said it is less than 0. So we have our -4 to be less than 0 for odd x. So from there we can say our answer is maximum. So from here our y is going to be 400 and our x will be 200 and the total area will be 80,000 meters squared. Now we have come to the end of this particular study session. We move to the next study session. Make sure you listen to the next study session, the next part of this study session, so that you can complete your study. Thank you.